Alright, today we're going to be working on section 8.1, the law of sines. We're going to use the law of sines to solve triangles, and we're going to use the law of sines to find the area, or we're going to use sines to find the area of a triangle when we have two sides and one angle. Okay, so first they kind of give you the basis of, solving right triangles. Some of the properties you need to remember is that all the angles of a triangle add up to be 180. So if you have two, you can find the third. Usually we use trig to solve right triangles, but now we can solve any oblique triangle. So here they give us 5 cases to look at. Angle, angle, side, side, angle, side, 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 angle, side, angle, side, and all 3 sides. Not all of these we will use for law of sines, only a few of them. The law of sines, here's how you derive that formula. So they show you if you have an oblique triangle, you can drop a perpendicular, make a right angle. And you can kind of look through here, good information showing you how using Pythagorean theorem and the properties of trig that we've already established to derive the law of sines. So here's where the law of sines is. It breaks down to side A over sine of angle A. That's going to be equal to side B over sine of angle B, which is equal to side C over sine of angle C. You can have it this way or you can flip it. It does the same thing. But once we have that formula, that's what we're going to use to solve these triangles. The most important part that we want to focus on is the examples that they give us, and I'm looking for the diagram here. So this is when we have two sides and an angle given. So side, side, angle. These are the different scenarios that will arise. So you might have no solution if one of the sides is too short, it does not make a triangle. One solution if it's a perpendicular, you get a right triangle. There is the ambiguous case where you can get 2 solutions. So this is the one we got to look out for. So whenever you're given 2 sides and 1 angle, we always need to check for this. Okay, the angle or the line could be drawn 2 different ways, and you'll get 2 cases. So this will pop up. You'll see that a couple times. If they're equal, you got an equilateral. You'll get 1 solution. Case 5, here you get 1 solution. And then some other ones that don't form triangles, you get no solution. So the most important part here is looking for 2 solutions, and I'll show you how to find that. And then they give you some examples with side, angle, side, and these we'll do in my math lab. I'll demonstrate those over there for you. And then there's one more formula, the area formula that we're looking for. Here we go, area of a triangle. So again, they show you how they derive the area of a triangle. So they tell you our area of a triangle is 1/2 base times height. And using trig, they derive a formula to find the area of a triangle. So there's 3 different versions depending on what side and what angle you're given. But you need to have the 2 sides and the angle that's in the middle of them. So you're always going to be using the letters A, B, and C. So we label a triangle A, B, C. And if we're using side B and C, then we're going to use angle A. If I'm using side A and B, I'm going to use angle C. And if I'm using A and C, sides A and C, I'm going to use angle B. So it's 1/2 the 2 sides times sine of that angle. So that's pretty straightforward. So once you have that, then we can solve and find the area of any triangle given 2 sides and the angle that's trapped in the middle of them. All right, so with that, we're going to go ahead and jump over to my math lab and start working.